Good morning, everyone, or good afternoon, rather. Hope everyone is doing well. Um, just give me 1 second here. All right, folks. There are a couple things I want to go over. Today is not going to be long at all. What we're going to do today is we're going to go over activity 80A, and we're going to go over activity 82. And that's it. I'm not assigning any new assignments for the week. So anything you have not finished, please make sure you finished. Also, please make sure that you go and check for any incomplete assignments. If you look at your average and your average is lower than you think it should be, you probably have an incomplete assignment somewhere that you have a 0 for. So please check it. Okay, go in, do the assignment. All right. I don't want you guys to have lower grades. The reason I put those assignments there for you, the reason I put the zeros in is to kind of alert you, hey, you're missing something. So please go in and complete them. Just because the zeros aren't there doesn't mean you can't complete it. Okay. I know you guys are going crazy because of quarantine. And hopefully some point within the next 2 weeks or so, we'll get some kind of resolution. But the whole point is to keep you safe, because I guarantee you'd rather be bored than sick and suffering miserably. So let's just try to keep it together. There is something I want to go over, and I'm not sure where people are finding it. So I think next week I'm going to be changing how things are done. I don't know if people are thinking that I'm not fully paying attention to what it is that they're doing, but I have been noticing that some responses have been copied from another source. Okay, you may not realize that. But number one, some of you have had identical answers to questions. And number two, they didn't really match what it is that we were doing, which means without paying attention to what it states, the answer was copied. For example, the lab that we did, the cloth in the lab was white. There were several people who in their answer talked about the black cloth, which is an old version of the lab. So clearly something went wrong there. Okay. Please make sure you are paying attention to the work. And I just want to say that I have concerns about actually copying the answers. The reason I'm actually teaching the content, you may have some classes that are not teaching the exact content that they were supposed to be doing, but the reason I am doing that is because the district is telling us we don't have a choice. This is a high school credit class, so we actually have to cover the content. Okay, it's not that I'm trying to be difficult. It's not that I'm trying to maintain, I am trying to maintain some kind of normalcy, of course, because I know for some of you, this is the only time that you have an opportunity to communicate with your friends. But I have to actually do this. The district, the science district department is actually mandating that I do this. We have to do the content. You have to understand it because you're going to need it for later. And not understanding it, well, thank you, Rosie, I appreciate that. Not understanding it is going to be a problem for you later. That's why I'm really trying to get you to understand it. But if someone has managed to find a source and they're copying answers from that kind of defeats the purpose. So please, 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 make an effort to do the assignments. Now, also, something I need to tell you, very, very important. So ears peeled. Monday is a non-student day. Yay. So you guys get to relax on Monday. So I'm not going to see you tomorrow. I'm not going to see you Monday. Our next class day is Tuesday. Okay. I would appreciate if you could try to get your assignments done before then. If all your work is caught up, you will have nothing from me. I'm not going to add any additional assignments. So Monday is a non-student day for you. Okay. Also, please make sure your stuff is updated, because a note will go out to your parents from the district, having them check grades because it's progress report time. Okay. So does anyone have any questions? I'm going to go ahead and open up to get ready to get started in the meantime. But if you have any questions, please let me know. Let's see. All right. So we are going over first activity 82 because that's the first thing we did. And then we're going to go over activity 80A, and then we'll be done. Okay, this is strange. Okay, can everyone hear me? I mean, I've been talking for about 6 minutes. Is everybody able to hear me? Can you just kind of post something in the chat? It'll also tell me if my chat is working. I saw Rosie posted something, but then after that, I'm not seeing anything else. Awesome, perfect. Glad to see that. All right, so in this model of the stopping car, so you guys saw the lab that I did, and in the lab, we had a piece of cloth that was on the strip, and that piece of cloth, awesome. That piece of cloth was a frictional force. Okay, so what was the point of the cloth? Okay, we know it was a frictional force. Why was that important? What was the cloth supposed to model? To create friction, but it was modeling something specifically. What was it modeling? The force that it was modeling was friction, but what in a car was it modeling? Not a brake. That is correct. The braking system. Is there anyone who does not know how a braking system works? Okay, just to let you know, when you step on a brake, you have the rotors in the car, and the brake, you have these two brake pads on the side that kind of hang out on the side of the rotor. And when you step on the brake pads actually clamp onto it, and there's a frictional force between the two surfaces that causes the car to stop. That's why you have to make sure you check your brake pads, because when your brake pads are worn out, the car doesn't brake very well. Okay, so they kind of sit like this, and then as the car, as you apply the brake, okay, if you apply the brake slowly, the brake pads will move in slowly. If you apply it quickly, then they'll slam on it and they'll try to slow the car down as quickly as possible. Okay, so that cloth mimicked, because if you notice, it started not on the ramp, but it actually started at the beginning of the white portion of the track. Okay, so you had the ramp where there was nothing there, and as soon as it hit the white portion of the track, now you have that cloth that was sitting there that was actually slowing down the vehicle. Okay, so it mimicked, okay, we went down the ramp, and as soon as we got down the ramp, now the brake was applied and the cart slowed down. But can anyone tell me what kind of strengths and weaknesses this model had? Okay, what was good about this model and what was bad about this model? Okay, and I'm going to ask another question for if someone else is trying to think of something. Did it successfully mimic, and where were the limitations? I know typing, unfortunately, leads to very awkward silences, but it's important to kind of get to know what's going on in your brain. By the way, I was really impressed with some of the answers that you guys did give. So kudos to putting some thought in that. And I also think that this particular branch of science, physical science, is one of the more interesting sciences. So since it's one of the more interesting sciences, I think you guys actually take to it a little bit more than all the chemistry that we were doing before. All right, so I'm not seeing any responses. So I'm going to go ahead and discuss it. The strengths. Well, did it slow the cart down? Yes or no? First of all. That is correct, Sabrina. It did slow the cart down. So it did have a system where the cart was actually able to slow down. Okay. So that was a strength of the model. It did what it was supposed to do. It did slow the car down, but did it actually mimic the braking system in a vehicle? What do you think? Did it mimic a braking system? Not quite. Although it did slow the cart down, the braking system, the frictional force was on the road in this particular case. It was physically on the track. The point was to show how a braking system slows a vehicle down. And it did show that it doesn't stop it right away, but there's a slowdown process. However, the braking system is triggered within the vehicle. It's not triggered on the road. So in this particular case, it did not effectively represent the real braking system of a vehicle. Okay, you can apply, and I mentioned this a few minutes ago, you can apply varied forces. You can either brake slowly, that's when you come to that nice smooth stop, or you hit the brakes really hard and you wind up jerking. Okay, you are unable to simulate that here. It was one and done. Okay, so number 2, what effect does speed have on the braking distance? Okay, so what do you think? Using evidence from this activity, what kind of effect did speed have on the braking distance? And I think this is something we've talked about several times. The faster you go, the more distance it takes for you to stop. That's exactly right, Andrea. And I don't know who Artisan is, but the faster the speed, the longer the braking distance. That is absolutely correct. Okay, so the faster the car is moving, the longer the braking distance is going to be. Okay, so of course, if you're speeding on a local road, you may not have much time to stop. Okay. Okay, that is correct. The faster the car is going, the longer the distance is required to stop. So Does the evidence you gathered in this investigation support the statement below? Oh, wait. Well, before that, before we go there, and I don't have the data up here, but when we started from ramp A, from the point A in the ramp, I actually think I have it here. So when we started from point A in the ramp, which was up here, the car moved a lot further. When we started from point C, the car did not move as far. So you were able to see that we were able to get as far as 40 something centimeters starting from point A, where we were down to maybe at point C, we were down to something about, I think it was the low 20s. Okay, so you're talking about a big difference in braking distance just by speed. And the higher up we were on the ramp, the faster our cart went. Okay, so going to number 3, does the evidence you gathered in this investigation support the statement below? Okay, so use evidence from your investigation to explain why or why not. So the statement is a car moving at 55 miles per hour needs less distance to stop than an identical car going at 45 miles an hour. Is that statement supported? And I know this question seems to be a little bit of a silly question, but I'm going to explain to you why it's important in a second. So is this supported? No, it is not supported. Not at all. Okay, in fact, it's the opposite. A car moving at 45 miles per hour would need less distance to stop. Okay, so the reason why a question like this is important, and some of you may have experienced this before, is because when you look at a question like this, you may get that question on a test. It's a seemingly simple question and you misread the question. So you want to pay attention to the wording of a question. Instead of reading a question and just answering the question, read it, digest it, think about what the question is saying prior to answering the question. Okay, that's really important because sometimes we get some really silly mistakes in answering questions, and it's because of the fact that the question is answered. You're answering the question, you understand it, but you're reading it so fast, you're not processing exactly what it's saying. So the data says that the fast moving car needs more distance to stop. Sabrina, you're absolutely correct. And that's what our data supports. Okay, so why do you think speeding is a factor in a high percentage of car accidents? My book gives a very lengthy response, but bottom line, why is speeding a factor in many car accidents? I got some really good answers for this one too. I will say I was really impressed with some of the answers that you wrote. Takes longer to stop the car, bottom line. So if you're speeding on a road, I will give you a perfect example of this. I was driving on I-75, and there's a point on I-75 when you're driving towards Tampa and you're going to the direction of Wesley Chapel where I-75 curves. And when it curves, for some reason, I don't know what's happening further down 75, but for some reason, at that point in the curve, all of a sudden, the car stops. Everything stops. So you could be driving along and people love to blaze a trail on 75, and all of a sudden you make that curve, you make that turn, and then there's a ton of traffic in front of you. So I experienced, I was driving, I stopped. There was a lot of, you're okay, Jacob. Okay, there was a lot of traffic, and all of a sudden, I'm looking in my rearview mirror and I'm thinking, oh my God, I'm gonna die. And the reason for that was because I'm looking in the rearview mirror and there are cars coming so fast. And one car swerved into the grass to stop. I mean, he actually had to jump into the grass, and it was an SUV, so he'd have killed me. He was big. And then another car wound up stopping, but had to kind of swerve partly off the road. So your braking distance is greatly increased the faster you drive. So speeding is a big part of accidents because people can't get to a stop fast enough. Okay. The greater the mass of the car, the harder it is to brake. Okay. So if you have a tractor trailer driving at 70 miles an hour versus a regular car driving at 70 miles an hour, it is going to brake really, really slow in comparison to the car, and you have a greater chance of an accident. So the mass of the car is really, really important. The next test is going to be, I believe, it's after activity 86 or 88. A couple of them we don't do, they're optional. So it'll probably be not next week, but early in the following week, or it'll be after we finish next week. I'll post the test and you'll have several days. But it's a good thing you did mention the test, because there is something I do want to mention about tests. I post the test, I give you several days to finish the test, and then once that test window closes, I open up the retake window. If you take the test and you don't do as well as you would like, you may take the retake. If you miss the first window for the test, yes, you can take it during the retake window, but there's not a third window that's going to open up. So you kind of shoot yourself in the foot a little bit if you miss the first window. So please pay attention to the windows of the test. Okay, it's not like I'm saying you have to take it by tomorrow night. I opened the last one, I think it was Wednesday night or Thursday. I think it was Wednesday night. And you guys had until Monday night to take it. And this one closes, the retake window closes on Friday night at 11:45. So you have time to take the test. Please make sure you're taking it. Okay. I know that there are some extenuating circumstances out there, and if a student is communicating with me, I can help them, but make sure you're taking the test and make sure you do your retake on time. If you choose to take a retake, you don't have to do a retake, but especially if the score isn't great, it would definitely benefit you. It's not going to hurt you. I look to see what the two scores are if there's a score in both columns, and I drop the lowest score from your average. So it's not going to negatively impact you. Okay, in case anybody was wondering, which terms of how to look at all of your assignments and what's submitted and what's not, you'll see both tests there. But when you look over to the right where it shows how much it impacts your average, there's a line there. It's not impacting your average at all. Okay. All right. So activity 80A. And after we go over this, we will be done. So choose one of the objects listed on the table to the right. Describe how an astronaut's weight might be changed if they visit the object. Okay. It's going to be hard for you to answer this because you don't necessarily have the table in front of you, but I do have something I want to say on the subject. Some of you did answer it correctly. Some of you did not. I didn't take points off if you misanswered the question, unless you just didn't really give me an answer at all. But some of you mentioned that, like, I remember reading one answer specifically this morning or last night where someone said they would be crushed if they went to Jupiter. That is true, but that wasn't the question. The question is, how would it impact your weight? So for example, on Earth, you would be heavier than if you were on the moon. So your weight would be less on the moon. Okay, if you were on Pluto, on Mercury, Venus, Mars, your weight would go down because the mass of those planets and satellites are less than the mass of the Earth, and therefore the gravitational pull is less. Okay, if you're looking at something like Jupiter, Saturn, Uranus, Neptune, if you're looking at something that's larger, let's say even the sun, well, if we were able to suspend disbelief for a moment and we were able to stand on the sun, then your mass would, the gravitational pull on you would be much, much greater, and your weight would register much, 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 much greater. Okay, so the larger the mass of the object, the greater the gravitational pull, the greater the weight of the person. The lower the mass of the object, the lower the gravitational pull, the lower the registered weight of the person. Okay, I hope that makes sense. Your friend tells you there is no gravity in a space shuttle which orbits 400 kilometers or 250 miles above the Earth. Do you agree or disagree with your friend? Okay, just type agree or disagree. Disagree. Your friend tells you there is no gravity in a space shuttle which orbits 400 kilometers or 250 miles above the Earth's surface. Do you agree or disagree with your friend? Okay, you would disagree. Okay, and the reason for that is because if it is orbiting the Earth, it's caught in the Earth's gravitational pull. The only way it's going to orbit the Earth is if it is in the Earth's gravitational pull. That is correct. It's being pulled to the orbit. Same as the moon. Okay, look at tides, and the moon is about 200,000 miles away from the Earth. Oh, I think it's 203,000 miles. I don't remember exactly. But the moon is 200,000 miles away, give or take. It is caught in the Earth's gravitational pull, and we see the effects of that every day. Does anybody know where we see those effects? Give me one word. You know, I haven't actually even had an opportunity to watch Interstellar, but I'm going to watch it. I have not had a chance. Tides, you are absolutely correct. Okay? Tides are the indication that the Earth and the moon are interacting with gravity, okay? And the position of the moon in regards to the Earth is actually what causes tides to behave the way they do. If you're interested in me giving you a brief explanation about this, once I finish going over all the questions, I'm happy to do so. I actually find it pretty interesting. If you want me to go over that, I'm happy to do so. But it's basically the position of the sun, the moon, and the Earth related to each other, and their positions is what impacts how tides behave. Okay. What do you think would happen to a satellite in orbit if it suddenly stopped? And I'm gonna write down Interstellar to remember to go ahead and stream that later. Rosie, remind me to mention Interstellar tomorrow, or sorry, Tuesday. But I am gonna watch it this weekend because I want to see if that's related. It would spiral down to Earth. It would fall and crash into the Earth. That is correct. Since it is caught in Earth's gravitational pull, if it were to fall, if it were to stop orbiting, okay, now I'm going to, well, it's not so much that it needs speed, but you are onto something there. If it's orbiting and for whatever reason it stops orbiting around the planet, there's two things that will cause it to stop orbiting. Either it got pulled closer to the planet and the relationship between its mass and its distance is disrupted. If it is orbiting naturally, okay, the moon, for example, is orbiting naturally. If you have something that has an engine that's driving it, the engine is what's controlling where it's orbiting. If for whatever reason something came along and knocked it out of its orbital field, and so now it's getting pulled towards the Earth, it'll crash towards the Earth. If something knocked it further away, that the Earth's gravity doesn't impact it enough anymore, it's going to go flying out. Okay, but generally speaking, if for whatever reason it just did not orbit anymore, it would literally come crashing towards the Earth's surface. Okay. Rosie, is there something? And Kip, you are correct. If for whatever reason it got knocked out of Earth's orbit going into the direction of space, whatever direction it was trying to travel in is the direction it's going to keep going. Okay. Rosie, was there something I could clarify for you? I think I actually have something that I would be able to post that would help explain that a little bit. Oh, the movie is confusing. Okay. All right. So I will get back to you on Tuesday about that. All right. So, but if something is orbiting, and for whatever reason it stopped orbiting, it would continue to fly out. But if it is something that's orbiting the Earth within the atmosphere or close to the atmosphere and it stopped for whatever reason, it's going to fall out of orbit into the planet. So where the satellite is located, it would probably crash in the Earth's surface, okay, unless it was knocked away from the Earth. Okay, so, all right, but we do have to look at where the orbit is. Okay, and I want to check something really quick because I haven't had to look at it in a while. Okay, so it is outside of the Earth's atmosphere. Okay, because the Earth's atmosphere is only 330,000 feet or 62 miles above sea level. So it's definitely outside of the Earth's atmosphere, but it is closer to the Earth than the moon is. So, okay. Any questions? And anybody want me to kind of show them how tides work really quick? Because I have gone over all of the questions. So I'm not assigning anything new. Obviously, I kind of set up class so that there were no new assignments. I don't know. I honestly didn't look. It's more of understanding how gravity works in relation to two objects. Understanding it would probably help you understand that. And I know that it does appear somewhere on the test. Tides, not necessarily, but understanding what causes them, which is the gravitational pull, is something you should understand. So, and it's something that would take 5 minutes to explain. It's actually really easy. So, starting Tuesday, we're going to work on a new activity. We'll probably finish the activities for the next test next week. And it's still on Unit E, so it'll still be forces and everything. So you can use everything I gave you to review. If there are any new things, I will post over the weekend just to kind of help you out and, help you prepare for the test. Okay. So does anyone have any questions? Specifically anything that I would need to do now? This is very strange. I want to look at the camera so that I'm looking at you, but at the same time, I'm trying to read. Okay, so it makes sense, I hope. All right, so if you guys have any questions, feel free to send them to me. In the meantime, we're gonna end the stream for now. So I hope you have a fabulous weekend. Enjoy Monday off. So it's a nice 3-day weekend for you guys. And I will see you on Tuesday morning. Bye.